A machine is sitting inside a glass case in Athens right now. It is green, it is corroded, it is broken. And it is the most dangerous object in the history of science. Not dangerous because it explodes, dangerous because of what it knows. Because buried inside those twisted bronze gears is a secret that rewrites the story of when human beings first learned to think like gods. And for over a century, we only had half of it. The other half dissolved into seawater 2,000 years ago before anyone alive today was ever born. Half a machine, half a mystery, half an answer. That was all we had. Until now. Because the thing nobody is talking about loudly enough is this. An AI rebuilt the missing half. Gear by gear, tooth by tooth. And what came out on the other side of that reconstruction does not match the story we have been confidently telling for 100 years. The numbers it produces are wrong. Wrong in the way that means we were wrong. And once you understand what this machine was actually built to do, the full picture, not the textbook version, but the real one, you will not be able to look at ancient history the same way again. So let us start at the bottom of the sea, because that is where everything begins. It is the year 1900. A group of sponge divers from a small Greek island called Symi are anchored off a barren rock between Crete and the Greek mainland. The rock is called Antikythera. Nobody lives there. Nobody cares about it. They're just riding out a storm. When the weather clears, a diver named Elias Stadiatis drops into the water. He goes down 40 meters, 50 meters, 60 meters. He hits the seafloor, and then he surfaces screaming about dead bodies. His captain thinks the nitrogen has affected his brain, so the captain goes down himself. He finds the same thing, except they are not bodies, they are bronze statues. Marble arms, a horse, a hand reaching up out of the silt, an entire cargo of ancient art scattered across a Roman shipwreck that went down sometime around 60 BC and sat there in total darkness for 19 centuries. This became one of the first major underwater excavations in history. Divers pulled up bronze statues that now anchor entire museum wings. They pulled up glassware, coins, jewelry. And in the middle of all that treasure, inside a wooden crate full of corroded lumps that nobody looked at twice, they pulled up something that looked like a rock, a shoebox-sized chunk of brown and green bronze that went straight into a museum storage drawer and sat there for almost a year. Then one day, it cracked open. The wood inside had dried out. The lump split. And somebody looked inside and saw a gear wheel, a precision gear wheel with teeth so fine and so deliberately cut that it looked like it had been machined in a factory, in an object from 60 BC, from a world that, as far as anyone knew at the time, had no business making anything like that for another 1,400 years. That was the moment everything changed. Except it did not change fast enough, because what followed was a century of getting it partially right, partially wrong, and very slowly closing in on an answer that the machine itself had been trying to give us the entire time. Here is what the experts agreed on for most of the 20th century. The Antikythera Mechanism was an astronomical calculator, an ancient computer made of bronze. You turned a hand crank on the side and a train of interlocking gears translated the motion into the movements of the sky. On the front face, there was a dial showing you where the sun and moon sat against the backdrop of the zodiac. There was a small rotating ball, half silver and half black, showing you the phase of the moon on any given night. On the back face, spiral dials tracked the Greek calendar, predicted eclipses, and even counted down to the Olympic Games. Wind the crank forward and you could see that in 53 months the moon would slip into shadow on a specific evening. Wind it back and you could reconstruct the sky from the night your grandfather was born. For decades that was the whole story. Brilliant, remarkable, a total wonder of the ancient world. But contained, understood, a device that did extraordinary things and nothing more than those extraordinary things. That was the box they put it in. And a British physicist named Derek de Solla Price was the man who built that box. In the 1950s and 1960s, he counted teeth. Painstakingly, wheel by wheel, fragment by fragment, he tallied every gear he could see and worked out the mathematical ratios between them. Because a gear ratio is not just a mechanical fact, it is a frozen equation. If one wheel has 38 teeth and drives a wheel with 127, that ratio is a piece of locked-in arithmetic. And if you know your astronomy, you can read exactly what calculation that arithmetic was designed to produce. Price found the moon. He found the sun. He published his findings. The world was stunned. Case closed. An ancient astronomical calendar, elegant and complete. Except there were only about 30 gears visible. 30 gears out of a machine that everyone acknowledged was broken, corroded, and incomplete. What had survived was at most a third of the original object. And the official story was quietly, comfortably built on the assumption that the 2/3 we had lost were not doing anything more interesting than the third we still had. That is an enormous assumption. And it was never proven. You cannot count the teeth on a gear that dissolved into the Mediterranean 2,000 years ago. So the assumption just sat there, unexamined, propping up the whole story, until the machine started leaking evidence that the story was wrong. Even inside the surviving fragments, there were things that did not fit. Gear ratios that nobody could fully explain, dial fragments with markings that did not correspond to the sun or the moon, extra pointer stubs that the official reconstruction had no slot for, tooth counts that only made sense if the device was tracking something the calendar model said it should not be tracking. Every honest researcher who spent real time with the fragments knew in the back of their mind that the clean version had loose ends. They just did not have a tool sharp enough to pull them. Then in 2005, something changed. A new research team pointed a new instrument at the mechanism, not the naked eye, not ordinary photography, not even a standard X-ray. They brought in a microfocus X-ray CDT scanner so large and so powerful it had to be shipped to Athens rather than the fragments being shipped to it. An 8-ton machine designed to see through 2,000 years of corrosion the way a hospital scanner sees through skin, slice by slice, layer by layer, building a complete 3-dimensional map of the interior without ever making physical contact. And what it revealed stopped the room, because the CT scanner did not just show more gears hiding behind the gears everyone already knew about. It read text, thousands of tiny Greek letters engraved across the bronze plates, hidden inside the corrosion for 20 centuries. Letters so small they had been invisible to every previous examination. Not scattered words, not damaged fragments of sentences. A complete instruction manual etched directly onto the machine itself. A user's guide written by the builder, still sitting there, still waiting, buried in chemistry that nobody had been able to see through until 2005. And what that text said began to quietly detonate the old story. Because the inscriptions described the sun, they described the moon, but they also described the planets. All 5 planets visible to the ancient eye: Mercury, Venus, Mars, Jupiter, Saturn. The text described pointers for each of them. It described colored spheres, meant to represent each one moving across a front display that the surviving fragments could not produce, because those components were part of the missing half. The machine was literally narrating its own absent pieces, telling researchers in its own handwriting what it used to be able to do. And that is the moment the comfortable, contained textbook version of the Antikythera Mechanism began to fall apart. Because the surviving gears could not do what the inscriptions described. The 30 gears could handle the moon, the sun, the eclipses, the calendar, but the planetary display the text was describing would have required a gear train far larger, far more complex, far more ambitious than what anyone had found. The inscriptions were pointing at a machine that was bigger and stranger than what was sitting in the case, and the fragment evidence suggested there had once been something there, mounting holes with no surviving gears to fill them, pillar positions that implied more layers, spacing that only made sense if there had once been far more mechanism than what remained. The gap between what the text promised and what the bronze could show sat open for nearly 2 decades. Tantalizing, infuriating, impossible to close with the tools available, until the tools changed again, because the problem by 2020 was not seeing the fragments anymore. The CT scans had handled that. Every surviving gear tooth had been measured and remeasured down to fractions of a millimeter. The problem was reconstruction. How do you take a confirmed third of a machine and compute the invisible 2/3? How do you test whether your proposed missing gears actually fit the physical space available? Whether the ratios they produce actually match what the inscriptions demand? Whether the pointers they drive would collide with plates that you know exist? A human researcher can hold maybe a handful of gear ratios in their head at once. The Antikythera Mechanism had constraints running into the hundreds, interacting in ways that would defeat any single mind trying to track all of them simultaneously. You would need something that could hold the entire puzzle at once without getting tired, without developing a preference for one theory over another, without quietly rounding a tooth count by 1 or 2 to make the math feel cleaner. In 2021, a team at University College London published a landmark paper in Scientific Reports doing exactly that. They fed the complete CT scan data, every confirmed gear, every fragment of every partial gear, every tooth count, every recovered inscription, including the planetary passages, and every physical constraint from the fragment geometry into a computational model. The model had one job: find the gear arrangements that satisfy every single constraint at once, and discard everything that does not. The result was a proposed reconstruction of the front face that, for the first time, actually matched everything the evidence demanded. Not just the moon, not just the eclipses. All 5 planets, each displayed on a pointer moving across the front zodiac dial, each driven by its own epicyclic gear train, each reproducing the characteristic motion of its planet in the sky as seen from Earth. And here is the part that broke the simple story completely, because those planets do not move smoothly across the sky. They drift forward for months, then slow down, then appear to stop, then appear to move backward for weeks, then lurch forward again. This is called retrograde motion, and for thousands of years it was one of the most confusing and awe-inspiring things a person could watch from a hillside at night. The official story said the ancient world knew about retrograde motion, but could not mechanize it. That the mathematics for modeling that backward stutter in bronze came centuries later. The computational reconstruction disagreed. Completely. The gear trains the model kept returning to, the arrangements that survived when every simpler option had been eliminated, were not producing smooth planetary motion. They were producing the stutter, the loop, the backward creep, a tiny bronze imitation of exactly what a planet does when you track it night after night across the sky. The builder had taken the single most bewildering phenomenon in the ancient night sky and reduced it to a train of interlocking wheels a craftsman could turn with one thumb. The tooth counts that made it work were not round numbers. They were not tidy. They were specific primes and near primes, awkward numbers like 53 that you do not arrive at by accident. 53 is a choice. 53 is someone sitting over a piece of bronze with the mathematics already worked out in their head or scratched on a wax tablet, deciding that this exact number of teeth, not 50, not 55, this exact number gets them closest to the planetary cycle they are chasing. Every strange tooth count the fragments carried that no previous researcher had been able to explain suddenly had a purpose. The damage was not damage, it was signature. The fingerprints of a mind doing something that the official story said should not have been possible yet. Think about what that actually means. The machine was not counting down to eclipses and stopping there. It was modeling the sky, not recording where the planets had been, but forecasting where they would be. That is a completely different category of achievement. A calendar counts. A calendar is record keeping. You can carve a calendar wheel without understanding why the cycles happen. You just need patience and observation over enough generations. But a forecast requires a model. A forecast means someone understood the geometry of the thing well enough to reproduce it mechanically. Someone had looked at the maddening, irregular looping paths of 5 different wandering lights in the sky, identified the mathematical pattern underneath each one, and then encoded those patterns into nested layers of bronze gears so that anyone who owned the device could turn a crank and know where Mars would be in 6 months without understanding a single equation. And the accepted timeline of when humans developed that capability just got pushed back. Not by a few decades, by centuries. Every textbook chapter that begins with the ancients could not yet model planetary motion is now standing on weaker ground than it was before. And that is not even the strangest part of what the reconstruction revealed. Because when the rebuilt gear train was allowed to keep running, when the simulation was not stopped at the planetary display but let continue through the back face as well, something appeared that nobody had told it to produce. The back face carries a long spiral dial that everyone already knew tracked eclipses using the Saros cycle, a 223-month astronomical cycle that brings the same pattern of eclipses back around. That much had been confirmed for years. Extraordinary on its own. But when the missing gearing drove that spiral in the complete reconstruction, the pointer was not just marking when an eclipse would come, it was carrying additional information alongside it. A secondary mechanism riding on top of the main one, turning at its own independent rate, providing details about the eclipse that no previous reconstruction had included. Details like whether the eclipse would fall in daylight or darkness, roughly how long the shadow would last, what the color of the moon might become during a lunar eclipse. The machine was not just predicting, it was describing. A person holding this device could have stood in front of a crowd on a named night and told them exactly what the sky was about to do, and the color it would turn while doing it, and roughly when it would end, and they would have been right. You do not grind that level of detail into bronze to show off at a dinner party. You build that precision into a device because someone needed the authority that precision provides. Think about what a darkening sky meant to ordinary people in the ancient world. No scientific framework to explain it, no reassurance from a lifetime of education that it was a predictable geometric event. Just the sun or the moon going dark and the genuine terror of not knowing what it meant or when it would end. A person who could stand up in that moment and say, I know what is coming, I know when it will end, I know exactly what it will look like. That person held a kind of power that had nothing to do with armies or gold. That was authority rooted in knowledge, the oldest and most durable kind of authority there is. And this machine, this portable wooden box the size of a thick book, had compressed a lifetime of mathematical genius into a form that anyone could operate. You did not need to understand the gear trains. You did not need to know the astronomical cycles. You turned a crank. You read a pointer. The hard part, the part that had taken a mind of extraordinary capability, years of observation and calculation to solve, was frozen permanently into metal and handed forward to whoever held the box. That is not a calendar. That is the first known example of one person's intelligence being transferred into a device and placed in the hands of someone who did not understand how it worked. And when that realization lands, the whole story of the object tilts in a way it does not recover from. Because if that transfer was already possible 2,000 years ago, then the thing we congratulate the modern world for inventing, intelligence poured into a machine and handed to a stranger who can use it without understanding it, is not our invention. It is a rediscovery. Someone did it first. Then it sank. Then we forgot. Then we did it all over again and called ourselves the first. And now the question sitting under everything is this: how much of what we call progress might actually be the second time? The reconstruction has not changed the placard next to the fragments in Athens. The people closest to this work are still arguing, carefully and quietly, in the way careful people argue about things that threaten established timelines. The bold version of what the AI-assisted model implies, a planetary forecaster, a full eclipse describer with color and duration, the first portable intelligence, evidence that the history of mechanized astronomy needs to be rewound by centuries, that version is still contested. Some of it may not survive further scrutiny. Science does not move the way a dramatic reveal works. It moves slowly, with resistance, with replication demands and peer review and the weight of careers built on the version that came before. But here is what cannot be undone. The machine's own inscriptions describe planetary displays. The surviving geometry of the fragments is consistent with a far more complex mechanism than 30 gears could produce. And the computational models, the ones that had no stake in a preferred outcome, keep converging on the same answer when all the constraints are applied at once. The corrections are not scattered. They keep pointing in the same direction, toward a device that did far more than the clean story allowed. And sitting underneath all of that is a person, an unnamed mind, almost certainly dead for 2,000 years, who understood the sky well enough to argue with it in metal, who solved the hardest observational problem of the ancient world, and then, instead of writing the answer in a scroll that could be copied and taught and carried forward, sealed it inside gears and handed it to a merchant ship. A ship that sank. A ship that sat on the seafloor for 19 centuries while the knowledge it carried was slowly, painfully, independently rediscovered by other people on the other side of that gap, who had no idea it had ever been done before. The world forgot so completely that when clockmakers in medieval Europe eventually worked out the same mechanical tricks, they thought they were inventing something new. They were not. They were finding it again. And we are still finding it again right now, one scan at a time, one constraint at a time, one tooth count at a time, pulling the outline of that lost mind slowly back out of the corrosion. We know how it thought. We can watch it choosing 53 over 52 and understand why. We can feel the decision in the metal. We just do not know its name. We do not know if it was one person or a workshop or a tradition stretching back through generations we have lost every other trace of. We do not know if there were 10 of these machines or 100 sitting on shelves and ship decks around the ancient Mediterranean, waiting for the sea or the centuries or the fire to take them. This might be the only one that was ever made, a single impossible leap by someone so far ahead of their time that when they died, the idea simply stopped existing and stayed stopped for 1900 years. Or it might be the last survivor of an entire lost civilization of precision mechanics, a tradition so thoroughly erased that not one other example has surfaced anywhere in 2,000 years of digging. We do not know. What we know is that the machine is still talking. Every new scan reads a few more letters the builder never expected anyone to see. Every new computational pass finds a constraint that the simple story cannot satisfy, and a stranger story that can. The box in the case in Athens is not done giving up its secrets. And the AI that helped rebuild the missing half did not solve the mystery. It deepened it. It showed us that the half we thought we understood was only the beginning. So here is the question worth sitting with when this is over. If a mind working with bronze and hand tools and wax tablets 2,000 years ago could build a device that compressed the entire observable cosmos into something you could carry in a bag, what does that tell you about human intelligence itself? Not about ancient technology, about the mind, about what a single person, given enough time and enough obsession and the right question, is capable of compressing into the world. And if that was possible, then, long before electricity, long before computation, long before any of the tools we assume are necessary for that level of thinking, what does it mean for right now? What is being figured out today, quietly, by someone nobody has heard of yet, that will sit in a glass case 2,000 years from now and make the people, looking at it, ask the same question we are asking tonight? Drop your answer in the comments. Because whether you think the missing half really does forecast the planets, or whether you think we are reading our own wishes into the gaps, that is the whole argument. That is the entire debate. Are we finally seeing what was always there? Or are we filling the dark with the shape we wanted?